Our next shuffle is the FARO out shuffle here, on the top row but on the right side of the display diagrams. So as you might guess, this is similar to a FARO in except for one slight modification. Okay, so what we'll do is we'll begin with an ordered packet of cards 1 through 8. And now what we'll do differently is we will take the bottom 4 cards. So we're splitting the packet exactly in half. Now what we need to have happen is we need this card to go underneath the top card here. And we'll do that by having the card on the left below the bottom card on the right. And then you just perfectly interlace them. So that is the FARO out shuffle. And it will give us the following new order. We will get 1, 5, 2, 6, 3, 7, 4, 8. And so that leads to a Cauchy two-line representation as follows. So the top row is always the starting order of the cards. And now we get 1, 5, 2, 6, 3, 7, 4, 8. And this two-line notation can be converted into cycle notation as follows. We see that 1 goes to 1, which means 1 is a fixed point. So whatever's placed in position 1 gets returned to position 1. If we follow what happens with 2, 2 goes to 5, 5 goes to 3, and then 3 goes to 2, so it wraps around. So we get a 3 cycle. Similarly, 4 is sent to 6, 6 goes to 7, and then 7 goes back to 4. So we get a second 3 cycle. And finally, 8 is a second fixed point. 8 gets sent to 8. So whatever starts in position 8 is returned to position 8 once the shuffle is completed. Now color-coded, we get the following. 2, 5, 3, all of which are color-coded red, and then 4, 6, 7, all of which are color-coded black. And then we normally don't write single cycles when describing a permutation in cycle notation, as indicated up here. We can drop those as long as we know the size of the set that we're working with. So if we keep in mind that the original set was of 8 objects, we can actually drop these. Now I included them just because of the color coding. So we see that black 1 goes to black 1, and we see that red 8 goes to red 8. So what this means then is all of the cards in the red value positions will stay within those positions in some order, and all of the cards in the black value positions will stay in that same group of position values. So what this will mean in particular is that each value gets sent to a value of the same color, and this means that inversion has not occurred. So this simply means that the cards in these positions will stay in those positions, 1, 4, 6, 7, and the same thing is true for the complement of A. Cards in these positions here will stay in positions 2, 3, 5, 8. Now they'll be moved around among themselves with 2 exceptions. Whatever's in position 1 stays there, and whatever's in position 8 stays there. All of the others are actually being permuted. So applying all of this to the Bessey sequence 1001, 0110 means that if we perform this shuffle, it will preserve that sequence form. So why don't we just quickly show that. So here we're performing a FARO out again. So we're going to take the bottom half. So we interlace them perfectly in such a way that the top card on the left goes underneath the top card on the right. So that is a FARO in. And what will happen is it will preserve that form. So we'll still get 1, 0, 0, 1, 0, 1, 1, 0, despite the fact that the ones are moving around among themselves, with the exception of the first one, since that's a fixed point. And the zeros are moving around among themselves with the exception of the last zero, which is a fixed point as well. And let's go ahead and just show you how the Bessey shuffle diagram was constructed. So if we use the information in our cycle notation of the permutation, we see that 2 goes to 5, 5 goes to 3, and then 3 goes to 2. So let's go down to the graph here. So 2's over here. So 2 is sent down here to 5. 5 is sent back up to 3. And then 3 is sent straight up to 2. And that completes that 3 cycle. So we say that the values 2, 3, 5 are in the same orbit. In a similar fashion, if we begin at 4, so we're looking at the second 3 cycle right here. So it's 4, 6, 7. So 4 gets sent up here to 6. 6 goes to 7, so straight up. And then 7 goes back to 4. So that is the second 3 cycle, for which we also say that the values 4, 6, 7 are members of the same orbit. And finally, we have these 2 fixed points. 8, whatever's in position 8, is returned to position 8. So it doesn't go anywhere in the end. The same thing for position 1. Whatever starts there will end there. Now I've indicated down below that this shuffle is the inverse of shuffle 10. And shuffle 10 is one that we've seen already. So recall that shuffle 10 is an even up jog for which the right pile is stacked on top of the left. And the way that we can tell that this is the inverse of the FARO out is the diagrams are identical except for the fact that the direction of the arrows is reversed. This of course means that if you perform the FARO out followed by an even up jog for which the right pile is stacked on top of the left, it will return that packet of cards to its original order. The same thing is true for performing the even up jog first with right on left, followed by the FARO out. It will reset the packet to its original order. And the FARO out is identical to shuffle 44, which is coming up later in the series.